In chapter 3, we had this with exponential functions. You have a base raised to a power will equal some number. And we said this is an inverse of a logarithmic function, which is a log with some base to a number equals the power. And we could convert back and forth. Here we have some properties just to simplify. What these refer to, the product, quotient, and power properties, are just kind of like what you would do with, say, a square root. You know that a square root of 25 equals 5. But you also know that if you had like a square root of something like 50, you don't have to, even though it doesn't have a perfect square root, you don't have to leave it like this. You could simplify this by saying this is equal to the square root of 2 times the square root of 25, which happens to be 5 times the square root of 2. And we could reduce a square root like this. Well, it's the same concept of the log. If you're given a big number, you could break it down into 2 different factors of that number and just break them apart. So instead of just looking at the symbols here, let's look at an actual example. Here it says express log 96 in terms of 2 and 3. Now 96 you could rewrite as factors. For example, 96, we could write it as 2 times 48. You could write it as 4 times 24. You could write it a lot of different ways. We're going to use the factors 2 and 3. So here's how I find the factors of 2 and 3. I take my 96 and I'm going to divide it by 2. 2 happens to go into 96 48 times. Now I'm doing what's called upside down division here because it leaves room to divide it a second time. If I divided 48 by 2, I would get 20. No, I'm sorry, I can't do math. 24. There we go. Not 29. If you divided 24 by 2, you would now get 12. And can 2 go into 12? Yes, it can. It goes in 6 times. So we keep going like this until we're out of factors of 2. So 2 can go into 6. 3 times. Now 3 happens to be one of those numbers, so I'll also include it in black. And so this is how you could rewrite 96. 96 is equal to 2 to the 1, 2, 3, 4, 5, fifth power times 3. So that's how I'll rewrite this. This would be log of 96 is equal to log of 2 to the 5th times 3. Well, the product property, let me put this in parentheses too. So the product property tells us that if we have this, we could divide these by the factors and say this is the same thing as log of 2 to the 5th plus log of 3. Now remember, these are called common logarithms. The base would be 10 here if it doesn't show one, which it doesn't. Now we have another that's called the power property here, and it tells us that the power you can actually move out front. We saw an example like this on last lesson. So I could actually move the 5 out front and say that this is equal to 5 times log 2 plus log of 3. This would be my answer. After doing all this work, we came up with this solution. Let's try another one. Here it says log of 32 over 9 in terms of log 2 and 3. Well, 32, I'm going to break that down into factors of 2 and 3. And so we would have 2 goes into 32 16 times. And 2 can go, that doesn't look like a 6. Let's try that again. There we go. 2 can go into 16 8 times. And 2 can go into 8 4 times. And 2 can go into 4 twice. So that's 2 to the 1, 2, 3, 4, 5, 2 to the 5th. So right now we have log of 2 to the 5th divided by, and I'll put a parentheses here so I don't get messed up. 9 is the same thing as 3 squared. If we're not sure, just 2 does not go into 9, but 3 does, and 3 goes in 3 times. So this would be 3 squared. So if I wanted to rewrite this, I could say that this is equal to log of 2 to the 5th power minus, because this is the quotient property, log of 3 squared. And now I would do the product property, and that just says move the products, or excuse me, I said the product property, the power property. Move the power property, move the power up front. So I have 5 times log of 2 minus 2 times log of 3. And this would be my answer. So we can, in a way, simplify, even though this equation expanded to be here, then the values of the logarithms became more simple. So that's what we're doing here with these properties. You go ahead and try this one, see what you can come up with.